Welcome back to Rosa Technocrat. In today's video, we will dive deep into FortiManager High Availability, covering both the traditional or the legacy failover mechanism and the new VRRP-based automatic failover. We will explore how each method works, their configurations, what's new in 7.4, and how FortiManager ensures continuous management of your FortiGate device during a failure. Let's begin. Can we, or is it possible to have a high availability between different FortiManagers at different locations or between more than one FortiManagers? In today's content, we will talk about how high availability is configured or how the failover mechanism can be achieved in a FortiManager. Let's consider we have three FortiManagers, one at each location, different location. So we have to check the possibility, or like we will talk about how there can be a high availability between the devices. So can we, or is it possible to have a high availability? Of course, yes, it's possible. Okay, so let's see how is it possible. Is automatic failover possible between different locations or multiple FM? We will discuss and demonstrate about FortiManager types of failover, and it's manual HA failover, automatic HA failover, and the troubleshooting of failover. When we talk about FortiManager HA failover, there are two types of failover that can be configured on FortiManager. So first is the legacy method or the old method. So this is the old method, and under the legacy high availability option, these are the limitations, or like how this works. So the old method supports one primary and up to 4 secondary FortiManager peers. Only primary FortiManager is active. So let's say if you have 1, 2, 3, 4 FMG, 4 different FMG, one will be acting as a primary and rest all will be acting as secondary FMG. Okay, so these all will be secondary FMG 2, 3, 4. So these all will be secondary and this will be a primary. So supports one primary and up to 4 secondary FortiManager peers. Only one primary manager is active, so only this FortiManager will be the active one and rest all will just hold this manager. Secondary peers only see primary as peers. That means everyone sees only the primary. They don't know about each other. So FortiManager 2, 3, 4 doesn't know like there exists a another FortiManager or different boxes. They only know about the primary. Failover needs to be done manually through GUI or CLI configuration change, and cluster members doesn't need to be on the same subnet because this is a like layer 3 reachability between all the peers. So you can consider like a manual gear car where you have to manually switch all the gears to have a primary or secondary configured. This is the gearbox of my first car, which was a Maruti Wagon-R. When we talk about automatic high availability, so automatic high availability is VRRP. This is the main topic that we were supposed to discuss today. So automatic high availability is based on the VRRP. So you know VRRP, Virtual Router Redundancy Protocol. You might have heard because anyone in the networking might be knowing about VRRP, Virtual Router Redundancy Protocol. So this method of failover in FortiManager uses the VRRP protocol, supports one primary and up to 4 secondary manager peers. So this still remains the same, like you can have up to 4 peers. Okay, so one will be primary. This still applies the same as the traditional of 4 manager peers. Only primary FortiManager is active, so this will be the active FortiManager. failover can happen without inter-user intervention. So this is the important or the most bigger difference between the old method and the traditional method, I mean VRRP method. What happens in VRRP method is like when you have 2 FMG, so there will be a VRRP protocol running between them and there will be a virtual IP assigned. This virtual IP will be pointing to the active one and they will be polling each other using VRRP, Unicast or Multicast. If the FortiManager detects no keep alive or no response from the secondary box, in that case this VIP will fail over and will start pointing to the active one. So this is how the failover happen without inter-user intervention. So this is a very good feature which was not there in earlier versions, and after introducing the VRRP failover, you can configure or you should configure the VRRP failover. Admin set priority for which FortiManager to be primary. So the administrator or the security administrator will configure the priority for the FortiManager who is going to be the active one. Now let's talk about manual failover. Okay, so I just told you about the features or how it works. Now let's see more practical. So under FortiManager, when you go system settings HA, you will be able to see these two settings, manual and VRRP. This manual is the old method or was the earlier method of failover, and VRRP is the new method of failover. So this was not there earlier. Okay, so when you click on manual failover, you have the option either it's a standalone box, that means there is no other redundancy, or you can configure it as a primary or secondary. Okay, so let's select manual, primary, and you can have 4 peers configured once the high availability is configured. So you can have 4 peers, as I told you. You can define peer IP. For example, you can say 10, 10, 10, 1, 10, 10, 10, 2, and so on, 3.4. It's not mandatory to configure all of them. You can just delete this if you don't have 4. Most people or most organizations have only 2 or 1. So you remove this. 1 means one box is this itself, himself. So this is first and this is the second. So mostly the organizations have only 2 FortiManagers. I very rarely, or like very big organizations with so many branches and different locations across the world will have multiple FMGs spread across the geo. So in that case you can configure all of them. For a normal scenario, you just need to have 1 configured. You have to define the peer IP and the peer serial number. So serial number will be something like FMG, VM, or a physical box, and this will be the serial number. Serial number can be taken from the dashboard or you will already have it with you. So once you configure the IP type, the peer IP and serial number, you have to define a cluster ID. Cluster ID can be any number from 1 to 64. It's better to have a different cluster ID if you have multiple FortiManager HA clusters in your group, in your organization. Define a group password. The group password is not a mandatory option. You may or may not configure, but this is better to configure so that it is good from a security perspective. And when these two FortiManagers communicate with each other, they verify the password before starting or forming the high availability. So you have to define the group password. Then you have to define these are like the default parameters: file quota, heartbeat, failover threshold. So heartbeat interval is like every 10 seconds they send keep alive or heartbeat packets to each other. Failover threshold, so the 30 failover, like 30 failed heartbeats will result in a failover or primary going down. And this VRRP and VRRP interface, they does not apply in case of a manual failover, so you will not see these options. This is the legacy or the old method of the failover: manual, primary, and configuring these options. Let's say FMG1 went down, and what happens after that? On the FMG3 you will have config system HA, and you will have a serial number pointed to FMG2 serial number. This you have to change to FMG2. Config system HA, config peer on the FMG4, again you have to change the serial number to 2. And on the FMG2 you have to delete the serial number of FMG1, and you have to add the serial number of FMG3 and FMG4. So these changes you have to perform if you are doing in manual mode. So it's like manually changing the serial numbers in the devices and pointing them to the secondary FMG2. So these are like manual changes. This is very difficult. So you just configure the high availability, they ping each other. But the only thing is like the advantage of this is they sync the database. But from a failover perspective, from a redundancy perspective, there is no benefit. So the main benefit or the purpose of legacy is like the DB sync or the config sync. DB sync or config sync between the FortiManager. That is what we are achieving, because from a failover perspective we are doing everything manually, so there is no much advantage from a redundancy or failover perspective. Only thing is configuration is saved between both of them. So why legacy HA is not 100% HA? I told you it's not 100% because there is no automatic failover. You have to do all the configuration manually. So admin needs to do several manual steps during the failover, because we have to configure the serial number everywhere, point them to the new device, new FortiManager. So this is all required in case of the old method. Can add operational overhead to reconfigure peers on FortiManager and FortiGates. And it's a non-intuitive, can cause split brain if primary came back. So let's say if this is the FMG1 and then FMG2. Okay, now this was primary earlier, this suddenly went down and you pointed everyone to this. Now this is a primary, okay, because that box is down. Now when this comes back, this will also be a primary, and in that case there can be a split brain, or they will say I am primary, I am primary. So that thing is called the split brain if primary came back. Now what are the pros? Admin can 100% control which peer is active. Of course even in VRRP we will be able to control, but here 100% control because we are doing the changes manually. And native support for geo redundancy, because anywhere if there are multiple box, we can have redundancy between all of them pointing towards the primary. Okay, so this is how the failover works on FortiManager using the manual method. It is a manual failover. Reconfiguration is needed from admin to elect a primary. Now let's talk about HA failover and what protocol, how it works. Under the automatic HA failover, what happens is we have two FMG, assume FMG1, FMG2. Okay, now both of these FMG will be talking to each other using VRRP multicast, VRRP multicast, and they will be using a communication port or VRRP interface, let's say port 2, okay, and there will be a virtual interface, and this virtual interface will be having a virtual IP, for example 10.10.10.1, and here the box IP will be 10.10.10.2, and the second box is 10.10.10.3. So this virtual IP will be pointing to the active one, active or primary, and this is secondary. Okay, now both FMG1 and let me change pen. Both the FMG and 1 and 2 will be sending keep alive to each other, the VRRP keep alive packets, and as soon as they detect there are no keep alives, the VRRP will fail over and the IP will start pointing to the FMG2. Now, when you check the MAC address of a switch or the neighboring device, you will have ARP entry, right? ARP entry. So under the ARP entry, you should notice one thing, or you should take know this: 10.10.1, 10.10.2, 10.10.3. These are the 3 IP address. This MAC address against the IPs will be same for 2 IP addresses. So let's say this is EEFFXX, the MAC address, and AB. Okay, so this virtual IP, this is the VIP, this is box 1, and this is box 2. So the virtual IP shares the MAC address with the box 1 or the active, and the second box will be having their own MAC address. Okay, so this you need to I got a query recently where they asked why the MAC address is same for 2 different IP address. So this is because the virtual IP shares the same MAC address with the primary appliance. So when these keep alives are not detected, this IP will switch over and will start pointing to the second box, and in the configuration this secondary will be removed and will automatically be made primary. And if you have FortiGates, okay, under the FortiGates which are pointing to the boxes, you will have config system central management, and they will be having serial number of both the active and primary, serial of 1 and serial of 2. So under FortiGate you will have serial numbers of both the devices, and the only difference is the VRRP can use multicast or unicast, So in case of the multicast VRRP, it uses multicast to communicate, and there is one more called unicast VRRP. I mean the method it works. So there it sends the VRRP using unicast between the IP address. This is helpful for scenarios where there is a L3 network but there is no same L2 domain, or the virtual machines or the FortiManagers are in a cloud or any other virtual environment where you cannot have layer 2 domain. So that's why we have multicast VRRP and unicast VRRP. Now let's discuss more in detail. Now let's discuss automatic HA failover configuration. So when you go under FMG HA, you will see SAM again. You have to select the VRRP method. Once you select VRRP, you can SAM select again. No. See, now the difference is when we were configuring the manual, we were getting the operation mode configuration. But under automatic HA failover, you cannot select this because this is selected based on the virtual IP or based on the VRRP configuration. You have to define the peer IP again the same like 10.10.10.1, the serial number, cluster ID, password, failover threshold. Now, this is where you select the VRRP virtual IP. I told like 10.10.10.1 is the virtual IP and 2 and 3 are the boxes IP. So this is 2. Okay. VRRP interface will be the interface that will monitor the FMGs. So P2 as per our diagram that I explained. So this is P2 is the VRRP interface. Okay, VRRP interface or heartbeat. And this interface, let's say P1 is our VIP. So this interface will be the virtual IP. Okay, where I am configuring .1 and .2. So this is our virtual IP. So virtual IP you have to define for this port P1, and then VRRP interface is P2. Priority, the member with higher priority becomes the master. Okay, so that's why because of this priority we don't define a mode here. Based on the VRRP, the method is chosen, or the one with the higher priority becomes the primary box. Automatic HA failover, multicast VRRP as explained. So you have got FMG1, FMG2. Under the config system HA, you will see set mode VRRP and failover mode is VRRP. Failover mode VRRP and HA mode cannot be set in VRRP mode because this is chosen by the priority of the box. Okay. You will have the peer serial number configured, priority, virtual VRRP interface. So these are the same things that I shown on the GUI. Same thing now we can see it on the CLI. Now when you check on the FortiGate Get System Central Management, you will see the serial number of primary and secondary both pointing. So that's the difference under VRRP. So FortiGates will have both the serial numbers and they will be pointing to a virtual IP rather than the physical IP of the box. Mode is automatically generated by VRRP and VRRP priority can be configured 1 to 253. Higher is most preferred. So the one with higher priority is the primary. One with the higher priority is the primary and this is secondary. So based on the priority, the box is chosen who is going to become primary in the high availability. When you talk about the communication between these, the VRRP, so if you take a sniffer on the port, you will see both the boxes will be communicating using the multicast IP address to send the heartbeat or the keep alive between the devices. So secondary FMG monitor 3 failed VRRP advertisement. This is important. 3 failed VRRP. That means if there are no 3 keep alive, okay, or failed 3 keep alives, then VRRP election based on the priority takes place and there is a failover between the boxes. By default, VRRP advertisement interval is 3 seconds. So 3 seconds means 3 second interval and 3 keep alives failed. 3 keep alive. So how many seconds? 3 plus 3 plus 3. because of the 3 keep alives, and each keep alive is sent every 3 seconds. So 3, 36, 39. So totally, this is the default configuration. So you will have a failover, the VRRP failover in 9 seconds. So VRRP should failover in 9 seconds. Why 9 seconds? You understood, right? So default VRRP advertisement interval is 3 seconds. 3 failed VRRP advertisement, 3 times 3 keep alives, or 3 advertisements. So totally FortiManager will fail over in around 9 seconds. FortiManager serial numbers will be resorted on FortiGate depending on who is the active, unless primary FortiManager goes offline, and HA state will not change. Okay, so this is all about automatic HA failover and the manual HA failover. Starting from version 7.4.1, VRRP manual re-election is supported. Like, you can force the re-election, and you have to use diagnostics HA force VRRP election command to do a force VRRP election on the FortiManagers. VIP interface can be different from VRRP interface. This is like 7.4.1. As I told, like earlier, I told this P2, P2, P1. So previous to 7.4.1 or earlier versions, both the VRRP communication port and the virtual IP should be same, but in 7.4.1 onwards, so you have different interface. Okay, so you can have, like as I told you, you can have even the VIP and VRRP talk on the same interface, but they will fail over. Now, Unicast VRRP, nothing. It's just the same. Everything works same. Just that instead of communicating on 224.0.0 series like the multicast, they will start talking on the L3 or the IP 10.10.10. 1 to 10.10.2. So the VRRP advertisement will be sent as a unicast rather than a multicast. That's the only difference. Rest everything works the same. So for that, the only difference is you have to enable this unicast. So if you want to enable this unicast, you have to enable this and select the monitored IP. Automatic HA failover. It's the same thing is explained again. After enabling unicast, FortiManager will start sending VRRP advertisements to unicast destination rather than a multicast. Config system HA set unicast enable. This is same setting as shown in the GUI here. In the CLI you can do using system config system HA set unicast enable. You have to enable it on both FMG, but in the GUI the configuration is sync. And the difference you will see when you take a packet capture, you will see now the unicast advertisements are sent on layer 3 between the IP address. Earlier this was sent on 224.0.0.9 some multicast IP address in a group. Okay, what happens when X primary recover? FortiManager Amsterdam has the highest priority 100, rest everyone is lower 70, 60, 80. So they are all secondary. Now if this goes down, what will happen? In case failover back is required, admin need to trigger failover back. Let's say this goes down to the next box 70, 60, 80. He will become the primary, and if this box comes back up, then you have to do the failover. In case failover back is required, admin need to trigger failover. Okay, that's the only thing, because we just don't want again to fail back immediately. So you can do a failover manually once it comes back. So how the failover will be triggered? You have to do diagnose HA force VRRP election, and then it will again check the priorities of the FortiManagers and done. So this will be again the primary. These are the useful commands for troubleshooting: get system HA, diagnose HA stats, diagnose debug application, force resync, VRRP election, sniffer, and HA status. So these commands will help you to troubleshoot most of the issues for a failover in FMG or any HA related issues. So what it does is get system HA status shows us the status of your FMGs, whether they are primary, secondary, and other information. While if you take packet capture or a sniffer, then you will be able to see diagnosis sniffer packet port to VRRP. So the VRRP advertisements are being sent. What you can see from here, this is like a Unicast mode because there is no 2 to 4 series communicating, and they are being sent like 42 every 3 seconds. 1, 2, 3. HA keep alive message. Then you have this command diagnose debug application HA 255, where you will be able to see all the debugs for the high availability. You can use this debug HA25. From the debug, it shows like what is going to happen or what is actually happening on the devices. So setting HA to secondary because this is not reachable. So this device is setting to secondary, and we will be able to see all the process or that is occurring whenever there is a failover or any issues or the keep alive in the diag debug application HA255. So 255, this is basically the level. It can be from 1 to 255 or -1 is the like everything. Okay. Verbose, you can say this is the verbose method or how deep you want to debug. So the numbers are from 1 to 255 for all the debugs on FortiGates or FortiManager mostly. What you should know? You should know, can we protect HA traffic using customer PKI? Like this is also a question. Can we have a certificate for the communication between the FortiManagers? So yes, you can use set local set. This is like an extra which you may not need. This is only required when you want to have a certificate being used between these two FMGs for communicate. So you can encrypt it by using your own choice certificate. Otherwise, FortiGate uses its default certificates. Does FortiManager support active HA? No. The answer is no. Why no? Because FortiManager only supports active passive, or you can call primary secondary. So does FortiManager support active HA? The answer is no. Only active passive. FortiManager supports only active passive. Having HA cluster does not change performance and capacity. Read-write management is only possible from the primary FortiManager. What if there is a firewall between HA peers? So if you have two FortiManagers at different location or sitting behind the firewalls, in that case you need TCP 5199, this port, to be allowed on the firewall, so that these two FortiManagers or the VRRP port is TCP 5199. So make sure you allow this. FortiManager communication that needs to be allowed: HA sync and health traffic is on TCP 5199 port. VRRP on IP protocol 112. only on Unicast less different layer 2. So Unicast and Multicast. What is synced between the HA peers? All changes to the FortiManager database are saved to the primary unit. Primary changes are then synchronized to the backup unit. So basically the configuration and every database, everything is saved on the primary, and the database is synced to the secondary. So it's a database sync, like config sync and the database sync between the HA peers. Database sync after each primary change. So once anything changes on the primary, there will be a database sync between the FortiManagers. What is not synced? The priority, host name, monitoring IP address, the system interface settings, FortiManager system static routes. Because if these things synced, then how they will communicate? So basically HA settings, network settings, and device settings like host name and priority IP address are not synced between the FortiManagers. What are failover conditions? Failover condition is based on the monitored interface. You have to define a monitor interface and the keep alive. That's it. So monitored interface you can define, and the VRRP advertisement interval. So if you monitor these, then the failover is triggered. Primary member failure like rebooted, shutdown or power failure will trigger a failover. This is first. Interface monitoring failure, like if you have the set monitored IP address configured, then it will trigger a failover. IP monitoring failure like ICMP, and FortiManager wait for 3 missed VRRPs. So there are like 3 situations or 3 different situations when failover can trigger. Box down, interface monitoring down, VRRP down. Is service impacted when upgrading FortiManager HA? Yes. FortiManager cluster will be inaccessible while upgrading. Service impact means you will not be able to make any changes on the FortiManager, but yes, FortiGates continue working and traffic keep on passing. So there will not be a network or traffic impact, but there will be management impact, and you won't be able to make any changes from the FortiManager to the FortiGates. Best practice: start the upgrade from the primary. Secondaries are auto upgraded by the primary peer, right? So you know how to upgrade. If not, we'll have another video, or we'll have a different video on how to upgrade a FortiManager. That wraps up our deep dive into FortiManager High Availability. We explored how Legacy HA works or the manual HA works, why it's limited, and how VRRP brings true automatic failover to FortiManager. If you found this video helpful, don't forget to like, subscribe, and share with your team. Thanks for watching, and see you in the next video.